Okay, I'll do a presentation of the practical realization. In the following presentation, first I'll calculate the elasticity coefficient, and then I will show the observation of the spring oscillation. In this experiment, I want to show whether there is a damping coefficient on every spring, and then I'll do a little summary. At last, I will show the video of the experiment of the damping swing. First, let's calculate the elasticity coefficient. As we know, this is the Hooke's law, so I use the clay to change the weight I suspend on the spring and calculate its coefficient. And at every spring, I do the 5 different ways, and average is elasticity coefficient, and it is in the red color. And this is my system of my spring oscillation. And at left is a ruler, and at right is a spring suspended clay under it, and I tie a rubber band on the clay. And this is the video of my experiment. Okay, after record the video, I use tracker to analyze it. And using tracker, you need to put a cross to do it to act as its axis, and you need to put a reference length as I put here, not that clear. And you need to find a reference point on the moving things, and it can help you to analyze it. And right under it is the data, and upper is the graph. So I copy the data to paste it on the Excel and to analyze it. And it is the data I analyze. And you can see this is the average coefficient of damping. I average on every point I analyze. And in the red column is the I delete some data is not that okay, so, and the blue column is the all of the data average. And this is the spring which is shortest, and the spring is second shortest, and the spring is second long, and this is the spring which is longest. And I'll do a summary. First, I want to talk of my result. First, we've found that every spring is with a very tiny damping coefficient, and the error is considering, so we can see that the spring will do like as a under damping action. And next, I will talk of the error. I think the error of this experiment is the action mode. I found that the class moving mode is not just oscillate up and down, but it also swing a little left to right. And it not only influenced the experiment, but also it was influenced when we are doing tracker, because you cannot find that the reference point is not that clear. And next, I will talk of the funny thing I found. It is the action mode. You can see that it is a graph which is the time versus the x displacement. I found that it also is a sine function. I think it's also a funny thing I want to talk to you. And at last, I want to show a video experiment of the damping swing. And you can see that in this system, the force of magnitude is act as the role of damping force. And this is the video. We can find that it is under damping video. And next, I try to increase its magnitude force. So it moves more slower, but it's still under damping video, but it's more closer to the critical damping. And next, I increase the magnitude force again, and we can find it move very slowly, but it becomes over damping. So next, I try to decrease a little. We can find that it moves more quicker than the over damping, but it also didn't move back and forth like under damping. But we cannot identify the critical damping and the over damping not that clear. So we just can do an approximation between over damping and under damping, and to guess a critical damping guess. So this is a critical damping I guess. Yes. And this is my presentation. Thank you.